Okay, good morning, all of you. We'll continue the problems involved with the torque due to dipole moment, motion of charge particle, and Ampere's force. So we'll begin with this question. So there's a loop A, B, C, D carrying a current I. So and there's a long wire carrying a current I naught, and the distance of, so let this be theta. This is the information given. OA is given A and AB as D, that one. So what is the net torque acting on this loop? Look at the loop now, where it is present in the field of long wire. No? So we are picking up a problem where how to calculate the torque where the loop lies in a non-uniform magnetic field. There's a long wire. So what is the field due to long wire? The field due to long wire, it will be a concentric circle around it. And where is the loop? The loop lies here. I think that there's a one way what you can. And this that dotted. Okay, there's a you look at the loop like this. So what are these? These are the directions of lines of force due to long wire, and this is that A, B, C, D. I think now you can manage. So this the current. Current I is flowing. Okay, let's directly come for that. What is the force experienced by the arc BC and AD? Should be zero. Any reason for that? How B bar? B bar will be tangential. So at these points, the B bar will be acting tangentially. So what are these? There's a thing, and similarly you can show it here. This one. How B bar will act tangentially to the arc AB, BC and AD. So therefore, what is the force experienced by that? Will be zero. So shall we put FBC and FAD zero? What is the first thing? FBC. Force experienced by the arc due to current in long wire, it should be zero. Now the only thing is about AB and CD, it will come into picture. So let me take a small element. Here, let it be dx. So let this element be at a distance x. Then B bar current, B bar, here how B bar will be, don't put into the plane. Current I is into the plane. So how B bar will be tangential. So the force will be into the plane here. So the df here on this small element will be like this. The force will be acting into the plane. Take Fleming's left hand rule. And similarly, you take one small element here. So if I assume one more small element. So again, at a distance x dx. So what is the direction of current? The direction of current is okay. There's a direction of current. So here how the B bar will be like this. So put no. So the force will be out of the plane here. Okay, so once you get this, rest will go for the other thing. Now the force acting on this element will be out of the plane. So what is the axis about which now the torque will be set up about this axis? This axis about which the loop rotates. Axis about which so find out the thing that one. So for that, how to get that one. So this is x, no? So let me take this as y. This distance, let this be dx. So now let's calculate the forces that are going to act here. So what is dF is equal to? dF equal to B naught current I into dA. So B naught equal to mu naught I naught 2 pi x I dx. The force. Okay, don't integrate. Keep it first here. So like that, the different elements here, different elements open, they'll experience different amount of force. And look at that perpendicular distance also. It will be different here. So how to get that torque? Shall we do one thing? Calculate total force acting on the segment AB. Then if you calculate total force acting on the segment AB, then what you are going to write y? Because different elements are at different distance. I think that's not a correct approach here. No? So what we do, torque exerted, torque set up by these small elements about axis first we'll calculate. Then we'll integrate, we'll get the total torque. This will be, this is the, what is the angle between DF and Y will be 90 degrees. Don't take this angle. This is not the angle between DF and Y. This is the angle between DX and Y here. So the DF will be out of the plane. So what is the angle between DF and Y will be 90 degrees. So that therefore the torque should be equal to the torque d tau. This should be equal to d tau is equal to, shall we write 2 df into y about that green color dotted line what I'm showing. So this is the, about this axis is what, about this line is what the torque is set up here. So then next after this, substituting this mu naught I naught I 2 pi x dx into y is also a variable, no? So the total angle is theta. So this angle will be theta by 2. So sine theta by 2 should be equal to y by x. So y equal to x sine theta. Because y is a variable, y is not a constant value to take it outside the integration. It should be replaced with 1. So from the triangle, sine theta by 2 is equal to y by x, that one. So y is equal to x sine theta by 2. So therefore this d tau will write it here. So this d tau should be equal to 2 mu naught I naught I. 2 will get cancelled. So let's take this pi. 1 x get cancels. So sine theta by 2 into dx it is. So what should be the limit now? Shall we put a to a plus d? We'll get the total torque. So mu naught I naught I pi log of a plus d by e. So what about the torque? How the torque will be? So shall we show? I'm showing only sense of rotation here. So some questions of this kind will come. So you have to be very specific. Already they've asked in advance. They just asked only about the, in what sense, what direction the torque will act here. So we can even calculate mathematically.
Sir, that should be only into D, no, sir. Their x and x will get cancelled, sir.
Oh. Sorry. dx. Okay, that's x is not there, no, in the denominator. This should be x. It will be a plus d. Only dx, no. So this should be d will come then. Okay, dx by x. No? So different types of some varying fields will come. So just be alert. Next application. Read the question. So there's a current carrying ring. Read the question. Meanwhile, I'll set the diagram.